Good evening, folks. Hello, everyone. So today's topic is fiber optics based medical applications. So let's dive in and see how fiber optics are used in medical industry and how it is used for the surgical purposes mainly. So the topic of contents will be what is a fiber optic cable and why are we using fiber optics? Then different types of applications of fiber optic cables, and we will also see the physics and the operation of the fiber optics. Then we will also see different types of fiber optics and how the fiber optics instrumentation system works, and then we'll see about how it is used in the medical related areas such as endoscopy, laparoscopy, and robotic surgery. Okay, so let's talk about what is fiber optic cable. So fiber optic cable, it is also called as optical fiber, which is flexible, transparent fiber, which is made by glass or plastic with a diameter thicker than the human hair. So that means that it's very thin and it is very minute. So which is often used to transmit light and which is usually widely used in fiber optic communications. So it is also used in illuminating purposes and imaging. So what is illumination purpose? So it's just can be used as lights. So maybe you might have seen in your hometowns or in homes, we'll use like a decorative tree, which is also a kind of fiber optic cable. Okay, so fiber optics are used to transmit data for longer distances with higher bandwidth than metal cable. So that means that you know uh, the metal cables have some resistance and lagging of the data. So that's why we use fiber optic cable so that we can transfer every data in a very fast way as well. So that's why every country is turning into fiber optic. So that's why you might have seen ads recently, fiber net by Geo or the Airtel. So everywhere we are using fiber so that the transmission rate and the internet is being used are very fast and secure. So let's see the differences between typical fiber optics and the typical metal cables. So what is the difference? So the transmission happens in fiber optics is in the light form, whereas in the normal coaxial cable. So what is a coaxial cable? So you might have seen in our old TVs, dish TVs, the cable dish cable is made up of metal inside, and you have a rubber around it. Then you have metal casing. Then you have the outer plastic material. So you can actually bend the that metal cable. Even if you bend, it will not happen anything. Whereas the other issue in the fiber optic is when you bend it, so it might break. So that actually affects the signal. Okay, so what happens? So the material which we use in the fiber optics is just plastic and glass. So that's why when you bend it, so it will break. Whereas in the normal coaxial cables, the plastic and copper wires are used. So that's the reason even if you bend it, so it's not have any issue. So the efficiency, if you talk about efficiency, so the fiber optics have the higher efficiency and it is very lighter in weight, and the diameter is small. So whereas when you compare to the normal metal cables, the efficiency is low because you have a lot of electromagnetic resistance is there. So that's why the cables have to be you should have a transmitter everywhere for a certain distance, whereas the loss in the cable is very less. And sometimes if the the lights are not properly emptied, then you have some issue. That means that it is not covered properly for the fiber optics. Then you will have losses in the signal. Then the cost. because it always comes to the cost. So the fiber optics are a bit expensive, whereas the metal cables are very less. So you can, for example, 1 meter of the fiber optic cable cost around, like 300 to 500 rupees, whereas the metal cable cost around, like somewhere around like 100 to 150 rupees max. So let's talk about the applications. Okay, so as I said, it is used as a decorative item in the lamps and chandeliers. So if you see the image number 2 over here, so that actually are used in the lamps, so which you must have seen in the decorative items in the home. So when it comes to medical field, it is used as a light guide. Okay, and also the imaging tools, and also used as a lasers. So when it comes to defense, so defense, they use, like they use to detect high quality sonar and wiring for aircraft and submarines and other field network. So that's why always army has a higher range of requirements. So that's why the optical fibers for army are like very big. So if you can see it over here, see the size will be much bigger than what we see for the normal cable for internet. Okay, then it is also used for data transmission, as I said before. Then it is also used for TV broadcasting. Okay, then as I said before, so these are the different type of applications. So let's dive in to the structure of it. So fiber optic cable is made up of 3 components. So first one is core, which is in the center. Then you have cladding, which is the outer covering. Then you have buffer coating. Okay. Then you have a jack. So that is the outer plastic layer, which is there for even for every metal, even for the metallic cable. So what is core? So core is made up of silica and doped silica, which is light transmission region of the fiber. That means that we use glass or silica so that light can be transferred. So you must have seen, even if you see the lightsabers, which is there in Star Wars, so there use the silica glass. So that means that that actually transmit the light. Okay, then the diameter of the core is depends on the application which is used for. So then the outside layer is protected by cladding. Okay, then let's talk about what is cladding. So cladding main function is to reflect the light back into core. So you don't want the light as a form of data should not lose, right? So that's the reason we need denser material, so that that light will not pass from that and it will reflect back. So that's why, so if you see the material diameter, if you see the density, so it depends on the core and cladding. So that ratio has to be always same, so that the capacity and the opacity of the fiber optic cable will be improved. So then what is buffer? So buffer is nothing but the outer layer. So we have different type of cables, right? So you must have seen yellow cables, which is used for LAN. Then you have the orange cable, which is used for telephonic and the other medical purposes. So the blue one, which you can see over here, which is used for mainly medical purposes and the other industrial purposes. So that actually defines the type of fiber optic as well. So that means that yellow defines the single mode cable. That means that only one type of signal can be transferred, whereas the orange have the multi-mode. So that means that many types of signals can be sent at the same time, whereas the blue one is used for the laser based applications mainly. So let's talk about the principle of it. So an optical fiber is a cylindrical structure that actually transmits light along its axis through the process of total internal reflection. So what is total internal reflection? So total internal reflection is nothing but, when the light is passing through the layer, so it has to reflect back. So that means that whatever data we are sending, it has to be captured so that, no, will not have any loss of data mainly. Okay. So what is the differences we'll see. Okay, so the operation consists of, as I said, the layers, right? So you have core and cladding. So if you talk about physics, so there is something called refractive index. That means that, whatever, you must have known the concept of reflection and refraction, right? So refractive index is nothing but, whatever, it's a certain range of index where it says that, uh, whatever ray is passing, it will come back. Okay, so we'll see how it is actually guiding it. Okay, so we have some of the physical properties also. So the light is emitted from the light source have a certain set of wavelength, right? So that wavelength is measured in nanometers, whereas the frequency is nothing but number of pulses per second. So that means that, it's nothing but pulse. Okay, so it's like, one blink per second, something like that. Okay, so that is actually calculated in hertz. So as I said, you have multi-mode and single mode, right? So the wavelength of single mode comes around 1310 to 1550 nanometers, whereas the multi-mode, the wavelength comes around 850 to 1300 nanometers. Okay, then now let's talk about ray theory of light. So what is ray theory of light? So it is actually to study the property of light rays such as reflection and refraction. So especially when the wavelength of light is smaller than the objects. Okay, so that actually has certain set of basic rules. Okay, so the first one is called, in homogeneous medium, the light rays are always straight line. So that's why you must have seen when a laser is point out, so it will always go straight, right? So the same way you have focus lamps. So the focus lamps actually shows how the light is transferred, right? So that's why if you have a circular lamps, then the direction of the light will go in that circular way. Okay, so light which is there can be absorbed or reflected, right? So when you put some light in the dark room, that means that it is the dark room is getting illuminated. That means that the light is being absorbed and it is being transmitted. So if you put the same light on a mirror, then it is actually reflecting, right? So the reflected rays lies in the plane of incidence, and the angle of incidence will be equal for reflection. That means that if you are putting the light rays in a certain way, then if the light is being reflected, that means that the angle, whatever angle is there, is actually same. Okay, so that means that if you're putting light in a certain way, you can actually see the reflection in the other way. Okay, then at the boundary between two mediums, okay, of different indices, for example, you have a light. If you put light in a water, so the light will not go straight. Everyone knows that. So the same way, if you put light in the normal air, it will go straight. Why? Because there is a different refractive indexes there. Okay, that we'll be talking about in next slides. So as I said, so if you see the reflection, right? So reflection is nothing but the best example for reflection is the water, right? So if you see any scenery which is next to the lake or ocean, then you can actually see, so that water has to be still. Okay, then only you can see the reflection properly. That means that whatever light is falling on the mountains is coming back on the water. Okay, so that means that, that's the reason you can actually see the reflection of the mountain, right? Same way, if you see refraction. So here in this image, you can see the pencil kept in the water glass is not looking straight. That means that even though the pencil is straight, but the pencil position has been moved, right? So that is nothing but refraction. Okay, then we'll talk about something called Snell's law. Before that, you can see. So here you can see the physics of it. Okay, so for the refraction, when the light ray is passing, that have a deviation. So that's why the deviation is not straight. So that's why there is a refraction. So if you can see the image over here, the light falling on the pencil is actually deviating a bit. So that's the reason the image looks closer to the glass. Okay. So then we'll talk about Snell's law. What is Snell's law? Snell's law gives the relationship between the angle of incidence and refraction. Okay. So in physical way, if you see n1 sine theta equal to n2 sine theta 2. So that means that n1 is incident index. Just a minute. Fine. Yeah. N1 is incident index, N2 is refractive index. So that means that, whatever it is transferring, so that means that we'll be talking about the physical way. So N2 and theta 2. So N1 is one interface and N2 is another interface. So for example, N1 defines the water, N2 defines the air, for example. Okay, then theta is nothing but the incident of the light ray. Theta 1 and theta 2 are nothing but incident ray in the air and incident ray in the, okay, we talked about Snell's law. Then we'll talk something about critical angle. So what is critical angle? So critical angle is nothing but the largest angle of incident for which the refraction can still occur. So that means that, for example, consider a light ray which is passing from water into air. Okay, the angle of incidence of light increases from 0 to greater angles will be less refraction. So once it reaches to the 90 degrees, then you can no longer see it. Okay, so if you see here, some light ray is passing, okay, at a degree of 90 degrees. Okay, so it is actually the refracted ray is not seen. So what is total internal reflection? Is nothing but anything greater than the critical angle. That means that every light ray is passing back. Okay, that is called as total internal reflection. Okay, so let's talk about what is total internal reflection. So it is when you define it, so that is a phenomenon that actually involves the complete reflection of light from a denser medium to rarer medium. So there has to be some conditions for total internal reflection to happen. So that means that light must travel from a denser medium to a rarer medium. And the second condition is the angle of incidence must be greater than critical angle. So if any light is following these two conditions, then the total internal reflection will happen. Okay. Now let's talk about, here you can see in simple. So when the light is passing in 0 degrees, every light is going back. Okay, if it is passing like in a 20-degree angle, that means that it is deviating into 27 degrees. So if it is passing at 30 degrees, then it is deviating to 42 degrees. Okay, so when do you actually achieve what the total internal reflection? So if you achieve the angle of 48.8 degrees, okay, if the light ray is passing at 48.8 degrees, then the effect of total internal reflection will happen. Okay, clear? Let's see the animation of it. So here the light is passing. Okay, here you can see that the light is stopping at the 90 degrees angle. Then in the last ray, you can see the light is being reflected back. Okay, now you can see the total internal reflection in the example. Okay, so if you see, if you pass a laser light in a circular cylindrical light glass box, then you can actually see the light. If you put in a certain corner, then the light is actually reflecting inside the cylinder, and it is actually going outside. So that you can see here. So for example, if a light is being passed, so that is actually transmitting from one end to the other end, right? So let's talk about the different types of fiber optics. So how do you define the modes? So light travels through the fiber following different paths are called as modes. So as I said before, you have two types of modes. So the first one is single mode and the second one is multi-mode. So single mode is nothing but it's very small. That means the fiber shrinks to the core so small so that light can only travel in one ray. So that means that in a single mode, mainly the light will travel in one ray. Okay, so that's the reason it is called a single mode. Whereas the multi-mode, the fiber has traveling to the core in many rays. So if you can see in the animation, you can actually find it. Okay, so it has actually a larger core which actually supports the transmission of the multiple rays. Okay, now let's see a bit of physics of it. Okay, so in the multi-mode, so you actually have two types. So the first one is step index, the other one is graded index. So what is step index? So step index is nothing but the core of the step index is made up of completely one type of optical material. Okay, and the cladding is another type of with a different optical characteristics. So it has higher attenuation and it is too slow for many users. So that's the reason you have something called as graded index. So in graded index, you have different types of variations in the composition of glass. Okay, so that's the reason. So the data which is used, okay, so that actually can travel at the speed of 4 gigahertz per kilometer. Okay, so it has two types of diameter. So the first one is 50 by 125. So what is that 50? 50 is defined the core, whereas 62.5 is also defined the core, whereas 125 micrometers or microns are the cladding. So here if you can see 50 by 125 is nothing but the core diameter and the cladding diameter. Okay, so if you can see for the single mode, the core diameter is just 9 microns, whereas the cladding diameter is 125 microns. Okay, so let's see the path of light over here. So if you can see the difference of core and cladding, as you can see, it is made up of many types of materials. So that's why the light can actually go in a certain set of angle. So that's why the index profile of the fiber will change. That's why you have the specific direction. So imagine the light is traveling straight, but here the light is not traveling straight. So it has a certain degree of angle. So that's how the working mode of graded index works. Okay, now let's see the light again. So the input impulse and the output impulse can be seen here. Okay, so as I said before, uh, the step index has certain set of microns. Then for example, if something is traveling here, so everything is going back. So if you see the output pulse, it has a certain way. So you can see that it is rising and it is going down. Whereas the graded index finger fiber has a specific type of output. That means that it has an optimum output. Okay, clear? Now let's talk about fiber optics instrumentation system. So as you can see in the above block diagram, we can understand how the communication in the fiber optics works. So as you can see here, you have three major parts. The first one is transmitter, the second one is regenerator, the third one is receiver. So transmitter is nothing but it's an optical fiber communication system that has a processor that has that takes the input signal from the sources device and made it to supply to light transmitter circuit. Okay, that means that the light emitter circuit converts the digital electronic signals into the light. So when it comes to the regenerator, in long distance transmissions, so the strength of the signal gets decreases, right? So basically the main function of the repeater or regenerator is to make the signals stronger. So in other ways, you can say that it's an amplifier. So it actually amplifies the signal so that electronic signal can be again converted into light, then that light is being transmitted to receiver. So what happens in receiver? Receiver function is to just receive the signal in the form of light. Then you have something called photoconductors or photodiodes that actually converts the light into electrical signal. Then that signal can be used in the further way. Now, till now we talked about fiber optics, all that stuff. Now let's talk about fiber optic applications in the medical technology. Okay, so what is endoscopy? So endoscopy is a procedure used in medicine which is used to look inside of your body. So for many things you can't for many medical application, you can't actually cut your body and you can see what is wrong inside, right? So in order to actually examine something inside, for example, the nose or throat or ear, you put a small tube, right? So doctor usually put a small tube and see how and then what they'll do is, they'll actually see how the structure of the throat is looking or not. Okay, so that is actually for diagnostic purpose. So it is not for treatment for the first thing. Okay, so the main application is to see what is wrong inside your body, where the places where you can't actually go. So there we use something like a tube. So that tube is nothing but made up of fiber optics. Okay, then what does the endoscope consist of? Okay, so originally the endoscopes are nothing but a telescope. Okay, the telescope is nothing but to see something which is far away, right? The same way, the traditional design which has featured in such a way, so you use certain set of small lenses which are separated by large gaps. Okay, you can see it here. So there are actually two types of endoscopes. The first one is the rigid endoscopes. The second one is the flexible endoscope. So the rigid endoscopes are nothing but, you can't bend it literally. So the flexible ones actually bend. So if you can see, you have different types of lenses and you have a space. That space actually gives like an amplifier. Okay, so whatever light is being transferred, so then in the end you have an angle. Okay, it's not straight. Okay, for example, if you want to see something straight, then use 0 degrees viewing angle. Then you want to see something down, then you'll see 48 degrees, then you have 45 degrees. So you have different type of modes in that as well. Okay, then in the flexible endoscope you have different type of um, materials. Okay, the first one you can see here, that is eyepiece, so that is actually connected to camera. Okay, the second one is the focus ring. So in order to focus the light so that you can see the image properly, so that's why you have a focus ring. Then you have something called control lever. So control lever is nothing but to control the light, so that some places you don't need much light. So if you have dim light also, you can see things clearly. So in order to control the light, so you have something called control lever. Okay, then you have something called working channel port. So that means that that actually gives power, so that the light can actually transmit. Then you have something called control body. Okay, control body is to control the mechanism. Okay, so in order to make that fiber to move in certain way, to move inside and have the different type of angles, then you use the control body. Then you have something called insertion cord. So in the insertion cord, what you will do, so you can actually put some working instruments, you can actually send them inside the tube, and then you can actually get the samples. Okay, so in the rigid one, you can only view, whereas in the flexible one, you can actually send the working instruments such as forceps or clipper or something like that. So then you can actually take something from that as well. In even in rigid endoscopy techniques, also you have bigger uh, channel where you can actually put the endoscope. Then in the down you can actually put the working instrument, whereas in the flexible endoscope you can actually put in the same tube. Okay, then let's talk about endoscopy system. So what is endoscopy system? So here in this image on the left side, you can see like a camera, so that actually get the uh, images. You have lights uh, on the other side to control, to see what is happening. Then the big hole you can see here, that is actually used for the working channel. So that means that anything like scissor or the forceps or anything, any surgical instrument can be used, so that you can actually take out the biopsy material, or the tissue, or sometimes if there is a blockage you have to remove, so we can use. Okay, so what is the endoscopy system? So it has a set of instruments, so that actually uses to see what is happening inside. Okay, so here you can see you have a light, you have a camera, you have a tool. Okay, let's see how the endoscopy works. Let's see the video. Here you can see that the flexible endoscope is going inside the throat, and it is going right to the stomach. Then you can actually see what is happening in the stomach. Then, for example, if you have any stones or something, that actually can be removed from the tool. So here you can see that stone or something can be removed with that working instrument. Okay, I hope it is clear. So what is laparoscopy surgery? So laparoscopy surgery is nothing but it's a surgical procedure that actually allows surgeon to access inside the abdominal area without doing many cuts in the skin. So that's why, for example, to do any surgeries, you need to have like three holes, one for working instrument, the other one for the light, the other one for to make gas. Okay, so you send gas in such a way so that our body can be inflated, the abdominal cavity can be inflated, so that whatever working area can be seen properly. Because that when you blow, when you have like burping or something, you have a gas inside your body, your belly looks bigger, right? The same way, so you use artificial gas so that you can actually grow the abdominal area, and then you can actually perform the surgery. So you can see here, in order to visualize something, so you're using a laparoscopy surgery. For example, uh, you can see the gas filled abdominal area, and for example, if you have to see something in the uterus or bladder or something, you can actually expand the area of the abdomen, and they can actually visualize it. Okay, clear? Then let's talk about the robotic surgery. Robotic surgery is nothing but it's very similar to laparoscopic surgery, but the only difference is you use robotic equipment in order to make this laparoscopy surgery. So here in this first image, you can see that you have two nurses who are actually placing the telescope and the working materials, right? Then the doctor is sitting um, on a console. So the console actually shows the it is like a joystick. Okay, so the joystick, what does the joystick do? So it actually controls the game, right? The same way, the joystick actually controls the instrument. So for example, in order to make the surgery from a distance, so you use a robotic surgery. So that means you have something called a robotic arm, so that actually captures, it controls the equipment in certain way, so that you will not make any mistakes. So for example, in the general laparoscopy surgeries, the doctors might make some mistakes, because you might not see properly sometimes. You're not holding the laparoscope properly, so that you might have chance of mistakes. So in order to avoid those mistakes, so you are using robotic system, where it actually controls in a precision way. Okay, so that actually helps you to have better surgeries, faster surgeries in a very controlled way. So here you can see one such system which is there in the market called DaVinci. So DaVinci is certain company which actually manufacture robotic surgery equipment. So here you can see the nurse is actually placing all the robotic arms in such a way, so that the doctor is sitting somewhere in a farther way, so he can actually control the instruments by using the console. So doctor can simply sit, doctor even don't have to stand near the patient and do the surgery these days. Okay, so this is the advancement in the medical industry using the endoscopes and laparoscopes. Okay, so here you can see doctor is actually performing on a dummy. So usually doctor has to get trained on the robotic surgery equipment, so that they can actually perform, because it is not like a simple surgical equipment. Okay.